for the trends, with the radius. What's the trends with the size? Give me 1 point. Hayden.
Alkali metals have the biggest atomic radius, or largest?
Alkali metals group 1 have the largest radius. Oops. Alkali metals have the largest radius. What else did you notice? One other point. Nick? Give me another one.
I put the noble gases and hydrogen have the lowest radiuses.
So group 18 have
And hydrogen.
hydrogen have the smallest. Okay. So and hydrogen. What happens between the alkali metals and the noble gases on a period?
They start to decrease.
They get smaller. So we've got 3 points happening. So moving left to right across a period. Oops. The size decreases. Does anybody have any other trend? Okay, look at, on the graph, look at your alkali metals. What happens to the alkali metals as you go down the group? So lithium's at the top of the group, potassium's lower. What happens as you go down the group to the size?
They increase.
They increase. What happens to the noble gases as you go down the group? They increase. So, moving down a group, the size increases. The negative electrons are attracted to the pole, well, to the positive pole, bless you, to the positive pole from the protons in the nucleus. And it is this pull that will decide if you're going to get bigger or you're going to get smaller. So, going left to right. So we're going to look at the trend going left to right. We said that going left to right, the size decreases all the way across, right? You've got your lithium and you've got your neon, and they slowly get smaller. And the reason is because that positive pull on the nucleus acts on each electron in that valence shell. So, if you are lithium, you've got 3 protons pulling. But if you're neon, you've got 10 protons pulling. So the more protons you have, the stronger the pull, the tighter you can pull those electrons into the nucleus. It's like a tug of war. You have 3 people pulling on one side, or you have 10 people pulling on one side. If they're all about the same strength and size, the one that's pulling with 10 people is going to be able to move that rope a lot further. So, the more protons, the stronger the pull. The smaller the radius, the smaller the size. The total positive pull is felt on each electron. Shielding by inner electrons is not a factor. Because they're on the same valence shell. Shielding is the blocking of the positive pull by inner electrons. So shielding is the blocking of the positive pull by the inner electrons. So going left to right, they're on the same valence shell, so they have the same amount of inner electrons. So shielding is not a factor. What's happening is each nucleus has more positive pull, so it's pulling those electrons in tighter. So as you go left to right, you're going to decrease in radius because that positive pull is getting bigger, okay? As you go down a group, shielding has increased. And the valence electrons are physically further from the nucleus because another energy level or shell has been added. As a result, the valence electrons don't have the full pull from the nucleus. Why is beryllium bigger? You're right, beryllium's bigger.
At this time, would all grade 10s please report to the cafeteria for their grade assembly? Grade 10s.
Okay,
Because the first one for your thing was 4 electrons, so it would be 2 in the first one, 2 in the outer, so the outer ones will get the most. And then oxygen, it's 8, so it has more of like a pole, and it'd be 2 and 6.
but they both have 2 inner electrons, so the shielding's the same. So the inner electrons are going to have no net effect. But it's the protons, yeah. Yeah. So beryllium has less protons, less pull. They have the same shielding. Sulfur is bigger because there's more shells. It's 1 row below. So sulfur has more shielding because it has more inner electrons because they're on different rows. And it's further from the nucleus, therefore feels the pull less. So it doesn't feel the pull quite as great as carbon can, because carbon's closer to the nucleus. All right, I want you to put these 3 elements in order from smallest to largest. Let's do nitrogen. Argon, and strontium. Strontium. What do you think? I didn't plan this, by the way. Emily?
I think is it strontium? Is that what you said?
Yep.
Then argon and then nitrogen.
Ah, are you going biggest to smallest or smallest to biggest?
Small space.
I asked for smallest to biggest. You got it backwards. Okay. This is a good point I want to make with you. If I ever say list them in order, you label the order. Because Emily verbally said it, but if she wrote it down, she'll write it down in that order. But it would be wrong based on the question. Whenever I ask you to rank something, put the ranking on it. Because you might very well mean the correct thing, but the way it's translated, it comes out differently. So, you're correct. Strontium is the largest, so you would put big, small. It's just a little extra step, but it could save you marks, even though you knew the right answer, but you put them in the wrong order. So this says smallest to largest. If you had reversed it, strontium, argon, nitrogen, but you labeled it correctly, big and small, I would give you it. I'd give you the mark, because you recognize which end is big, which one is small. Do you know what I mean? Sometimes when you read a question, you read it so quickly that you rank it in an order that might be the correct order, but it might be reversed of the question. Your brain works too fast sometimes. So do yourself that little bit extra and label it when you do write it down, because it could mean the difference between a mark. Okay? Does that make sense? All right. Good job. Strontium is on the furthermost out valence shell, so it's got a ton of shielding. Its distance is further from the nucleus, so it feels the positive pull less, even though it's got a huge positive pull, because it's got a ton of protons. Then argon is 2 rings in, so it's not as far from the nucleus. Still has a bit of shielding, but it has more shielding than nitrogen, which is even closer to the nucleus. So the closer you are, position-wise, the stronger the positive pull. Let's talk about electronegativity. Okay. I'm going to be, when I write electronegativity, I'm going to use quite often short form EN, electronegativity. Okay? So what trend did you notice in electronegativity values? Did anybody have a zero value? Who's the lowest?
All noble gases have 0 value.
All noble gases. So all noble gases have a value of 0. Who has the next lowest value?
The alkaline.
Yeah, group 1, alkali metals. are next lowest. Did you notice which group had the highest values? Yeah, group 17. The halogens have the highest value. So, the smaller you are, the more control you have over other atoms' electrons.